Hey, you guys, it's me, Miss North, um, coming to you today with our today's lesson of continuing graphing proportional relationships. So let's go ahead and get started. Let's start with a little brief warm-up, just to get our minds working, just to get our brain pumping. Let's start with our do now. The equation y equals 2.75x represents the rate in barrels per hour. So we already see that we're already given a m. I want you to complete the table. If x equaled 1, what would y equal? If x equaled 5, what would y equal? And if x equaled 10, what would y equal? Then I want you to write me a statement of what the statement or the problem what about the statement or your problem made this proportional if it is proportional. So let's take a minute and let's fill those out for me. So now let's see if what you put in your ed puzzle match what Ms. North had. So when x was 1, I had 2.75. When x was 5, I have 13.75. When x was 10, I have 27.5. So two things that Ms. North saw, and your answers might vary, but they should be a little bit similar to what I was saying, that I knew that this was proportional because each y variable was a multiple of a constant. So basically, remember, multiple means I had to the answer from a multiplication problem, right? So I knew that I had to multiply 2.75 times whatever x was to get my y. And that's what makes it proportional, because we did not add anything in the end, that they're literally just working with factors. We're just really working with multiplication problems. That's what makes it proportional. Also, that it created a ratio, which means, again, that this m had to be times by that x to get the y. And another thing that you could have added that I didn't type in is that when I multiplied my constant by 0, if I made x 0, y would have been 0 either. That's always your first little hint. Y would always be 0 if x is 0. If I give nothing, I get nothing. So today's learning target, y'all, we're going to be, again, expanding on EE5, so we're graphing proportional relationships, interpreting the rate of change as the slope of a graph. Today, I want to be able to use multiple representations to compare two different proportional relationships. So I want to see, let's go ahead and review what we've already learned. A proportional relationship, like we just said, goes through the origin. So that means it goes through 0, 0. So that means it goes through 0, 0. And if you look at your graph down here, you'll see that it started, this is what I mean by goes through 0, 0. It goes through the little corner. So what we're going to start off today with is just building what we already know, just building those building blocks back. So Ms. North plotted 5 points on this line. And basically all I did was take the 5 points and that I plotted and put them over here. So I have 1, because I went over 1, because halfway between 2 is 1, 2. And then I went up 5. Do not count this as 1, because remember, you're halfway between 0 and 10. So remember, you're going to count 5, 10. So then the next one is 2 and 10. The next one is going to be 3 and 15, and 7 and 35, and 10 and 50. I always want to make sure you remember how to plot those numbers, that if they give you dots, use those dots they gave you. Use those plots. So, going back to still what we learned. Proportional relationships create a ratio, meaning that there is a constant number being multiplied to the independent variable. Your independent variable is always x, to get the dependent variable, which is y. So we're going to see, we still took our same graph of water and time. We're still going to use these same points that we found on our line, and we're going to put them into a table. And in the table, I want to see, well, what did I do from 1 to get to 5? What do I do to 2 to get to 10? What do I do to 3 to get to 15? What do I do to 7 to get to 35? And what do I do to 10 to get to 50? With all 5 sets of numbers, I multiplied them all by 5. So I want to start looking for those little patterns that we've already know that we see. What pattern? What was the same between each different number set? So then the constant number is the number that we multiplied to all the independent variables is the rate of change. So if I got 5 for each one of these, if I had to multiply 5 by each one of these sets to get the dependent, then that means 5 is my rate of change. 5 made it is my unit rate. And so then I'll notice that it's proportional because they do not have initial value. So clearly I didn't have to add anything at the end. 1 times 5 equals 5, and I got my dependent variable. I am done. I don't have anything else to add. So let's start off with a little launch problem. I'm just going to switch back and forth. But I just want to, again, get our brains working, seeing how we're comparing two things. So Jacob read 2 books, right? He read book A, and I'm sorry, y'all can't see what I'm writing. He read book A, and he read, I'm going to move it right here. He read book A, and he read book B. Okay? In book A, it said he read 150 pages in 1 hour and 10 minutes. In book B, put a little line there so we separate that. Book B, he read 275 pages in 2 hours and 5 minutes. So I'm going to move my hand so y'all can see again. Y'all remember Miss North is left-handed, so a lot of times we have to wait for her to finish writing. But anyway, I know that if I haven't read any pages of the book, I'm going to start off at 0, 0. No minutes, no pages, right? Then, looking at the 50 pages in the minutes, but usually my time is always my X. Because I can control time. Remember, I control when I work. I control when I clock in, when I clock out. I control how long I read the book. I don't want to read a book no more. I'm not going to read a book no more. I control time. So basically, whatever you can control is always your X. So I'm going to put that over here so we remember that our X is time. Now, let's think of another thing. I really like this problem because it's just, again, a brain stretch. Anytime that you have variables that are not the same unit, such as we have hours and minutes, they have to be the same unit. And hours and minutes are not the same unit. So, however, I know that 1 hour equals 60 minutes. So basically, I have 1 hour equals 60 minutes plus my 10 minutes additional. That's 70 minutes. So for X over here, I'm going to put 70 minutes. 70 minutes, I still read 150 pages. I'm going to do the same thing over here. No time, no pages. 0, 0. And again, I have 2 hours. So 2 hours equals 120 minutes. Plus my 5 minutes additional. In all, it was 125 minutes. 125 minutes for, 125 minutes to 275 pages. So let's see, how do I get here? How do I get from 0 to 70? I'm going to add 70. How do I get from 0 to 150? I'm going to add 150. How do I get from 0 to 125? I'm going to add 125. How do I get from 0 to 275? I'm going to add 275. Remember, my M equals the difference of Y, which is 150, over the difference of 70. I'm going to get my calculator. Mm-hmm. 150 divided by 70 gave me 2.14. I'm going to do the same thing over here. My M equals 275 over 125. 275 divided by 125 gave me 2.2. So now, just going back to our question, which book did he read faster, and how do you know? So if this rate of change was 2.14, that means I'm reading 2.14 pages per minute. And this means I'm reading 2.2 pages per minute. So which one am I reading faster? I'm reading book B faster. That M is bigger. 2.2 is bigger than 2.14. So then that was, like I said, just let's refresh. So, our task for today, you need to get a piece of paper. And I'm actually going to come out of here. I want you to take your piece of paper and I want you to split it into 4. Okay? So, let's look at our first 4. Our first little 4. Each of the top 4 collectors in the food drive gathered food at a steady rate in pounds per week. The food drive lasted a total of 26 weeks. The collectors kept written records of their food collection as shown, but none were wrote down in the final weight of collected food. So, basically, let's go ahead and see. We have 4 people. So the first person is Max. So on my first little square, I'm going to write Max. Max recorded food in his collection. So let's look. And I can actually make Max super bigger so that we can see it on the split screen. Alright, we see Max. We see Miss North's hands. Alright, so Max had 2 points. So we know that this is proportional. So Miss North can start with 0, 0. I love starting with 0, 0. If you don't want to start with 0, 0, you don't have to. But I love starting with 0, 0, especially when I know that it's proportional. Max also gave me 5 and 43.5. Okay? So, from Max, I'm going to find what is his rate of change. So, Ms. North is going to simply make my X and Y table, my first point being 0, 0, my next point being 5 and 43.5. So then I want to see, well, how do I get my rate of change? Remember, your rate of change is your difference of Y over your difference of X. So I want to see, how do I get from 0 to 5 and how do I get from 0 to 34? I want to start with the difference of Y. So I'm going to see on my Y side, how did I get from 0 to 43.5? I literally just added that. 0 plus anything gives you that anything. So 0 plus 43.5 gives me 43.5. 0 plus anything gives you that anything. 0 plus 5 gives me 5. So then therefore the difference of Y is going to go on top, which is 43.5. The difference of X is going to go on the bottom. I'm going to get my calculator. 43.5 divided by 5 gave me 8.7. And I want to put that back into the terms that we were. We're measuring pounds per week. So remember, this is always your first statement. Your Y is always your first statement per your X. So that means that Max collected 8.7 pounds per 1 week. Okay? So now we're going to go to our next one. Our next one, y'all, is Maya and Miscellaneous. So I'm, again, just going to make it a little bit bigger for us. Maya used the equation Y equals 8.75. So, where Y represents the pounds of food collected and X represents the weeks that's passed. So, I'm going to write in my square Maya. And we're just organizing our thoughts so that when we get ready to answer this question, we know what we're looking at. So, if Maya used the equation Y equals 8.65, I know that the equation for proportional relationships is Y equals MX. And the only thing that I want is the M. So in this instance, 8.5 is the M. So I can go ahead and just take from that. I don't have to figure anything else out. And I can take that Maya's pounds was 8.65 pounds. I'm sorry. Per week. And hey, I'm done with Maya. Miss Lynn recorded her process in a journal entry. I weighed my donations. So we're going to go to our next square and we're going to look at Miss Lynn. Miss Lynn recorded her progress in a journal entry. I weigh my donations at the end of every 3 weeks. So at every 3 weeks, I had 27.3 more pounds of food. So that's literally saying at 0 weeks, I collected nothing. So 0, 0. But at week 3, remember weeks is your X. At week 3, I had 27.3. And that pattern would have kept going. Because it said I had 27 more pounds every 3 weeks. So I'm going to do the exact same thing I did for Max. I'm going to move that up a little bit. Whereas my M equals the difference of Y over the difference of X. How do I get from 0 to 27.3? I literally add 27.3. How do I get from 0 to 3? I add 3. So then therefore, my rate of change is 27.3 over 3. So then I'm going to take my calculator. 27.3 divided by 3 gave me 9.1. So then let's write that back into my statement of she collected 9.1 pounds per week. And we have one more person. I'm sorry, I don't know why you used to be so small, but okay. So now we have Myron. Myron charted his collections. And so basically he says for 4 weeks I collected 35.6. For 8 weeks I collected 71.2 and so on and so forth. So basically on our last square we're going to put Myron's. So for Myron, I'm going to really just recreate his chart. But the great thing about, y'all know that it's a constant rate of change. The great thing knowing that we're already working with proportional relationships is I don't have to do the whole chart. I only need to find the difference between 2 sets of variables. So I'm going to literally just put the first 2. We already know that weeks is my X, so I'm going to put 4. And the correlating number to 4 was 35.6. And then the correlating point to 8 was 71.2. Now you can see at this one we did not start at 0. So we have to figure out how do I get from 35.6 to 71.2. And that's not a mental math kind of thing. So I know that if I started at a smaller number and got to a bigger number, I had to add. So if I want to find out what number did I add to that small number to get to the bigger number, I'm going to use inverse operations, which literally just means I want to do the opposite of what I actually want to do. So if I wanted to add, the opposite of adding is now subtracting. So to find out what my difference of Y is, Ms. North is going to go up here in a free space and have 71.2 minus 35.6. And again, we're not doing mental math, so no shade. Pull out that calculator. 71.2 minus 35.6. And I don't know if y'all can see it in my calculator. It literally gives me 35.6. So then therefore 35.6 plus 35.6 gives me 71.2. And I just want to check, because I know a lot of times we're like, check your work. I don't know how to check my work. I don't know what you mean. I've already done it once. Check it again. 35.6 plus 35.6 gave me 71.2. I just want to make sure the statement I'm saying is right. 35.6 plus 35.6 will give me my next variable at 71. And then we do know 4 plus what gives me 8? 4 plus 4 gives me 8. So let's go ahead and go into our unit rate. The difference of Y over the difference of X. 35.6 divided by 4. My difference of Y divided by my difference of X. 35.6. Can you answer your calculator? Divided by 4 gave me 8.9. So let's go ahead and make that back into our sentence so we're easy to translate and interpret what we have. So that means Myron collected 8.9 pounds per week. So we have all of our people. So we have all of our people, and it's just for convenience sake, this was Max, this was Maya, that was Melissa, and Myron. So we have all their unit rates. Max was 8.7, Maya was 6.65, Melissa was 9.1, and Myron was 8.9. So, which collector gathered the fastest rate, and what weight was each competitor at 26 weeks? How do you know? So off the bat, we already know. So off the bat, we already know that. So Ms. North turned the page. So I want to make sure that we all were very clear of what we've done. So after we found everyone's rate of change, I created an equation. So Max's equation was y equals 8.7x because his rate of change was 8.7. Maya's rate of change was y equals 8.65x because her rate of change was 6.5x. Millicent's rate of change was 9.1, so her equation was y equals 9.1x. And Myron's rate of change was 8.9. Therefore, his equation was y equals 8.9x. We already know that we said weeks equals the x. And right now we want to see, well, how many pounds would they have gained if they already went to 26 weeks? So basically, if it's 26 weeks, I'm going to plug in y equals my constant times the amount of weeks I want to find out for. So I'm going to take my calculator, and I'm going to say 8.7 times 26. The answer I got was 226.2. Correct? So then therefore at 26 weeks, I collected 226.2 pounds. Okay? So I want you to do the exact same thing for the following. So then we're going to go into just again a share. How can we learn who collected the fastest? We found out that it was Millicent because she indeed had the highest rate of change. So then comparing her, she had the highest unit rate. That means she collected the most food. And we know that here. Max only collected 226.2 pounds. Maya only collected 224.9 pounds. Myron collected 231.4 pounds, where Millicent collected 236.6 pounds. So I hope that was super helpful. Again, this is all it means. I know we did 4 for the video, but you all remember I learned type you only do 2. So that's what I mean by comparing. Can you tell me who did the most, who did the least, even by how much? How did I know? And then how can I connect my unit rate and how much my unit rate is of how much other people would collect? So I hope this was super helpful. Of course, we all miss you greatly. Can't wait to see you guys again. Do great. Contact any of us if you need us. Have a great week, y'all.